Okay. Okay. So this is basically an updated um video on the learning outcomes of um what's this? The learning outcomes of computer systems, which is the fundamental concept. We're not gonna be doing much writing, but however, I just wanted to say that I think I am just going to go back and do updated videos on my posted videos because I noticed that in some parts my network was giving me a problem. So it was quite hard for people to understand what I was saying. So I am to update once again. So this here that we're doing now is I think maybe I should change my pen into black. So we're going to be doing, I don't like colors. Course 1521, which is the code that we're using at my university. You can say computer, don't know if I spelled it correctly, systems, maybe number one. Okay, I'm not going to start with number one. I just want to explain what this module actually is because people actually use the plots. Yeah. So this module acts as a bridge to theoretical computer science, which is course 1501, and Introduction to Programming 1, which is your course 1511. So course 1501 is theoretical computer science, which questions us on how we should think mathematically about computing. So you see things like your sets, your proofs, and your number systems, right? Um, um, and etc. So that basically teaches you how to think logically and formally, right? And then when you look at course 1511, which is Introduction to Programming 1, that basically teaches you how to instruct the computer, or I don't know, it can be a calculator, it can be your phone. It teaches you how to instruct it, right? So once we start doing things like variables in programming, obviously, variables, your data types, or your inputs and outputs, and all of that. So that basically teaches you how to communicate with the computer. You are communicating with the computer as you are instructing it. And the computer is going to bring back some information. So it can be an error information, it can be what you compiled. So the compiler can be anything, right? So you are communicating with the computer and you understand what is happening behind all of that. Okay. And then when we look at course 1521, which is the computer system or fundamental concepts, that basically teaches you what happens to a computer when the program runs. So if, for example, you could take course 1501 or theoretical computer science and introduction to programming 1, and then this module basically explains the computer system that makes both of them work. So the proofs that you keep learning and um, the programs that you are building, this module is actually going to teach you why it all works and why the information comes back to you all within seconds, right? Okay, learning outcome one. So I'm just going to read it. Learning outcome one is to demonstrate how data is represented, manipulated, and stored in a computer by means of number systems, Boolean algebra, Karnaugh maps, and truth tables, and basic logic circuit drawings in context of a given problem. So we're going to look at everything regarding Boolean algebra, Karnaugh maps, logic gates, um, and so on. So here, we will be towards, or you will be towards how computers actually think. So basically, in basic terms, humans think using words, pictures, and languages, right? Computers, in the other hand, it thinks using 0 and 1, right? And everything basically becomes binary. If you think of binary, you're thinking of 2-digit numbers or a set of 2 numbers because it's bi. And that said, every number system starts from 0. And here in binary, we would have obviously 0 and 1, right? Where once we start looking at logics, you will be able to know what 0 stands for and what 1 stands for. So when you're sending in a hello message to on WhatsApp to your friend, the computer actually, you obviously would see things like hello, right? But the computer would actually have to convert this to, I don't know, it can be anything, right? It was a bad example starting with 0, but yeah, it can be anything. Okay. So in the computer, 0 is actually ignored, and hence why I say to you it was a bad idea starting with 0. But this is basically because everything is stored as numbers, right? So once we start looking at the ASCII tables, you will be able to know how to convert words or text to numbers or binary, to be exact. So if you could link this to theoretical computer science where you study logic, truth values, and your true and false, here you'll see those truth or those logics being applied. So in this case, 0 being false or off system, and then 1 would mean on or true. So hence why I say also I made a bad mistake by starting with the 0 because this would actually be ignored as the system would be off here, right? And then if you could link this again to Introduction to Programming 1, you write, let's say you were to write if mark is greater than or equal to 50. So you basically see an if statement, but the computer would see true or false. So if mark is greater than or equal to 50, a condition happens. So it either does not happen or it can happen. So it can be true, it can be false. Okay, obviously also once you start doing things like your Boolean algebra, you see stuff like this. And then we're going to look at a Boolean algebra too with regards to computer systems. So in COS 1501, you see things or you learn logical operators such as your intersection, or you can say your and then you see your union, which is your or, and you can see your not, right? Now here you will learn how those logical operators are being implemented logically, right? For example, if you search computer and science on Google, Google would basically look for pages containing both computers and science, right? So it can be conjoined to being computer science. If you search computer and science, you'd get computer and science. And then we look at, again, the logic gates. Basically, the inside of the computer, or inside the computer, there are electronic circuits called your gate. So once you start looking at those, you'd be quite interested. So for example, if you have AND gates, so this is not an example, it's a fact. Both values or inputs should be 1, and by that I mean, so if I were to draw in a table, let's say this is A, and that's B, and that's the outcome, right? So if the value of A and B are both 0, the outcome would be 0. If A is 0 and B is 0, the outcome is 0. If A is 0, B is 1, the outcome is 0. But if both are 1, so both inputs are 1, then the outcome would also be a 1. So that's your AND gate, basically, which is literally the same as the truth tables in theoretical computer science. And then we're going to look at Karnaugh maps. So a Karnaugh map helps simplify logical expressions. For example, making a complicated circuit simpler, or you can say smaller and faster. So instead of needing like 20 switches, you can simplify to 5 switches, which would be less cost, less hardware, and then the faster performance, right? Think of your calculator, for example. If you're typing in something, you want it to bring back an answer to you as quick as possible. Okay. Okay, so your learning outcome 2 is to basically demonstrate an understanding and an understanding of the basic functions of a computer, the software development process, and the units of hardware and software components. I'm going to talk about that shortly. So what are they teaching? Here they're basically teaching us what makes a computer. So if you look at maybe number 1, which is your hardware, you think physical things, right? So you think things like your keyboard, your mouse, your CPU, which is the brain of the computer, your RAM or your RAM, and your hard drive, for example. And then in software, you think of programs, right? So you think of programs here, you think of things like your Windows, your Chrome, your WhatsApp, and your C++ program. So if you link this to Introduction to Programming 1, where you would write C out, and then you have hello. If you think of this, your code doesn't magically appear on your screen. So the computer must first read the code, compile it, load it into memory. When you think of memory, you think of 0 and 1. And then obviously the ones that means on would be loaded into the memory. And then the computer should also execute the instruction and then display the output back to you, right? So thus COS 1521 explains that process. So this module that I'm doing here explains that process. So software development process. So before writing your code, you have to understand the program, design a solution, write the code, test it, and then maintain it. For example, when you're building a house, you don't start with bricks, but a plan, then foundation, and then software basically works the same way, right? So if you're thinking maybe of designing Windows, for example, or a chat app, you basically have to understand and then design the solution, write the code, test it, and then you can bring it out to the people. Okay. Learning outcome 3. Almost done. Learning outcome 3 is to demonstrate an understanding of the basics of data communications and networks. So here we're going to be learning how computers actually communicate back to you. So what happens for them to bring back the information to you? By this, I don't mean you communicating to the computer, like writing in the code. I mean, and I literally mean computers communicating to you, okay? So for example, if you send in a hello message to your friend, the message would travel through your phone, and then the cell phone tower, and then to the internet, and then another network, and then your friend's phone, all within seconds, right? So suppose one day you want to create a chat app or website or an online store, the program must communicate across all networks. So this module basically teaches us the foundations or the fundamental concepts of computing. So if I live in East London and my friend is maybe in Australia, I don't know if it's the same place, but if we're that far apart, if I send a message to them, it shouldn't matter where they are. So the text should come back to me from them. Right? Hope you do understand. Outcome number 4 is basically describing data structures and how different databases function. So here we're going to describe, as it says, data structures, and then and the databases, and then we talk about how they function together, which would be the relations, right? So data structures are ways of organizing information. So here you are organizing information. So in real life, if you were to think in real life, say my pen, don't know what's going on with the pen. Okay, so I said here you're organizing information, right? So when organizing a bookshelf, you can organize it by organize the books by the author. Author can be subject and then the date, right? So obviously with date you would go from oldest to the newest or the latest. And then with subject, it can go from Romance, maybe old Romance or Shakespearean Romance to the modern Romance. And then the author could be the same people, right? Or if it's two authors, it would go by, I don't know, if it's two authors in one book, would start by maybe one author, and then the dates would vary. So that means I don't know, something. So you're organizing information. The organizing is the same, but the information is different. So here the author is obviously can be the same, or they can change. They can change. So if you're done maybe with author 1, can move on to author 2, and author 3. So that means when you walk into a bookshelf or a library, when you're looking for specific books, it's easier to find because everything is organized, even though the information is different. Like the Romance titles here would be different and the days would be different, but the organizing is the same, right? So a computer example would be if you think of sets, a set, um, so if you think of sets, a set of elements, for example, data structures are a practical way of storing collections of elements. So if you think of things like your integers, or so your integer sets, you storing in the different types of sets would be the different ways of storing. So it can go from lowest to biggest, it can go from biggest to lowest, it can be anything. You can start with even number integers up to and then start with the odd numbers, integers. It can be anyhow. So you store in your data structures, you structure it, right? With databases, it's quite different because there you're storing in information instead of structuring. So for example, I'm just gonna draw in a table where in this table there's student number and then there's the name, right? So let's say, don't know, maybe this thing. Okay, so this is an example. So here you can think of this as data structures because student numbers are stored aside, and then you have names being stored aside, right? But it's also a database because now we're storing in information. Instead of calling me by name, you can call me by my student number. Do you understand that? Um, instead of calling me by my student number, you can call me by name. But it's now quite different if you call me from instead of my student number to my name, because another person could have the same name as me, but now the stored information is different because they would have a different student number to mine. If you think of IDs, or was I think it's identity documents. If you think of those, we can have the same name, but our identity documents would be different. So you can store us as a collection of, or organize us as twins. So each twin has been organized, maybe from female to male twins. But now with the databases, it would be different because now each twin has their own information, right? Their own separate identity. Even if the organizing is the same, the information would be different. And here we basically talking about the information. So for example, if you think of things like your uni registration systems, your banking systems, and your hospital records, all of these rely on databases more than data structures, right? Linking this, we're almost done. I'm just going to sum up everything. So linking this to theoretical computer science, where you study relations, here you study or you learn relational databases, which is built around relationships between data. So for example, another example, if you have, or if you are a student, I don't know if I spelled it correctly, I didn't, maybe it's very weird. So student, if you're a student, they will tell you which maybe course you're doing, or based on the course you're doing, you'd go to a certain campus, and then the course tells us who the lecturer is. So the lecturer. So these are basically mathematical relations, like how you would have the discrete maths, which is your theoretical computer science, but they are basically made more practical when you come to computer systems, right? How they all work together. So I'm just closing it now. If you could imagine building a car, so COS 1501, which is theoretical computer science of discrete maths, would basically teach you the maths behind it. So why does the engine work? So you calculating certain things, right? It can be the physics, it can be anything. And then COS 1511 would basically teach you how to drive. How do I operate this car? So you'd ask yourself certain questions, right? And then COS 1521 would basically teach you how to open the bonnet. Like, for example, if you ask yourself what parts are inside the engine and how do they work together. So that relates to everything. I know I haven't really spoken about programming 2 or introduction to programming 2, and that's because I haven't really mastered it. So I don't want to teach something I don't really know that well. Okay. Next time we come back, we're going to do things like our number systems, where we're converting decimal numbers, or numbers that you see in real life with your naked eyes, or that you can interpret with your naked eyes, to binary, which is what the computer sees, right? So we're going to learn that, and then we're also going to learn how it loops, basically, and then from there we can move on to other number systems. Thank you so much for joining. It was nice having you here.